So we had a chance to hear what cities have done in this past code cycle. We're really looking forward to hearing some of the opportunities for this upcoming code cycle. And I know we've all been eagerly awaiting to hear what the statewide codes and standards team has come up with. So I will, without further ado, introduce Misty Bruceri, and she's right here, and she'll introduce the team, and they're going to dive right into the findings and updates on their cost effectiveness studies. So.
Very much, Rachel. I think probably many of you, if not most of you, are familiar with the cost effectiveness studies and the role that they play in this process. And probably if you're not, somebody's come up to you very urgently if you've talked about REACH codes and said, you must have a cost effectiveness study. And so they are a big key in the local energy code adoption process. And for many years, the utility statewide codes and standards team has been working with local governments to provide technical support, mostly in the form of the cost effectiveness study, as we've identified that the studies actually require a great deal of work, and they're rather complex, and it's actually a lot more efficient to do the study once. And many of the assumptions, many of the things apply broadly. And so it's a lot more efficient than everybody repeating the study over and over again. Also, we can do variations and things like that. We provide technical support in the form of that cost effectiveness study, but the program also provides a lot of other support if you're interested in that. We can provide model language, help you with outreach, with presentations if you need a little bit of help, if you're going to do some outreach, things like that. At the request of several local governments this cycle, as we've all been discussing, the interest in REACH codes has grown tremendously recently. And so at the request of several different local governments, in this cycle, we started with 2 new construction cost effectiveness studies. So there's a residential and a non-residential study. And the studies both include a mixed fuel and an all-electric baseline. And in addition to that, they include packages for energy efficiency and also for efficiency plus renewables. So the studies have actually changed in complexity this time. They've kind of grown exponentially, and we have a lot more options. But I'm not going to stand in your way too long. I know everybody's really anxious to hear the results. I do want to remind everybody these still are draft results. We do not have certified software yet. And I know if you've heard me speak before, you've probably heard me say that many, many times. But they are indeed draft, and there are still some changes coming. Okay. So first, Bill Dakin from Frontier. Actually, let me back up just a moment. The team hired both Frontier Associates and TRC Energy Services to do these 2 studies. Both firms are very involved in both code development and REACH codes work, as well as implementation and educational work. And they've been involved for many, many years. And so they've got a lot of expertise with the software and also with the different options and packages and putting those kinds of things together for people. First up, we're going to have Bill Dakin from Frontier Associates. He's the engineering director there, and he is going to present the results from the Res New Construction Study, followed by Farhad Farahman from TRC. He'll be presenting the results from the non-res study. Once they're finished, I'll be back, and I'm going to go through and just talk a little bit about how you might use those results. I'm going to try to break them down a little bit and look at the kind of the basics of the results and how you might take a next step. Okay, so without any further ado, I will turn it over to Bill Dakin.
Thanks. Hello, everyone. So I'm going to start off here and talk about. I can use it here. Can everybody hear me? Talk about the residential cost effectiveness. Now, what I'm talking about here is we're talking about single family, low-rise multifamily. So that's 3 stories or less. Farhad will be talking about the non-res code. What we looked at when we did our REACH codes is now in the residential code in 2019, we actually have two baselines. We have a mixed fuel baseline and an all-electric baseline. And so we looked at both of these cases. We also looked at an all-electric case, code compliant case, 2019 code compliant case versus a mixed fuel code compliant case. The software we used, I'm just putting it up there. This version actually came out the day before we did our first draft. So as soon as we got our first draft out, then we had to rerun everything because there was changes. So as Misty said, you know, things changing. We think most of the, at this point in time, the residential software is pretty well established. We don't think there's going to be any significant changes to the baseline. They did make some changes in this version with what the assumed baseline for the all-electric case was in this last version. What also is different here with the residential code is in the next one is we're not doing percent better than compliance margins. We're doing an energy design rating, which takes into account total household or total building energy use, which includes plug loads, lighting, appliances. And this energy metric is what's used now. You're going to have a efficiency EDR and a total EDR, which includes the solar in it as well. What the results that we're going to show here are we're going to show them as a delta EDR because EDR will change from building to building, so you can't really use that as a kind of an EDR target. We're looking at it as a delta EDR target as kind of a goal for these next code, REACH codes goals. Yes. Yeah, so delta EDR is because the standard EDR is going to change no matter what kind of building it is. So it's similar to kind of a compliance margin. So it's a delta EDR between the standard and the compliance. So currently to be code compliant, you have to meet the EDR. So a delta EDR would be, if you wanted to do a REACH code, you'd say EDR that's, 2.5 points below the code. Cost effectiveness, we looked at both the TDV metric, which is what's used for the California Energy Commission, and that's what's used for, basically the standard that's used for developing code. And we also looked at, because local jurisdictions are interested in what the customer cost effectiveness is, we also looked at a customer-based cost effectiveness, which in this case, because all new homes will have, or new low-rise residential buildings will have solar, we're using time of use rates, and we're basing upon the rate structures that we got from the utilities that are based upon what's going to be in effect for January 2020 or reflective of that. We also looked at GHG emissions, and I'll show you some results on that. Yeah, so TDV is the time-dependent value of energy, and I don't have, that will take 20 minutes to talk about that, but that's what's used to basically, that's the metric that's used to evaluate code compliance. EDR is based on a TDV metric. So EDR is a design rating, which is 100 for a 2006 IECC compliant building. 0 means it's a zero net TDV building, but the TDV metric is being used. It's based upon TDV BTU per square foot of building. So this is quickly just showing you what the kind of the characteristics of the differences between the mixed fuel and the all-electric building. And I don't want to spend a lot of time here, but I just want to show that this is the first time where we actually have an all-electric water heating as the base case. And in this case, it's a these are all based on the federally regulated minimum efficiencies for equipment. And the state has to maintain that. For our studies, we are looking at looking at efficient packages that go above code that do not mandate these federally mandated efficiencies. So we're sticking. We did look at both federally preempted packages that could use more efficient equipment, but we're also looking at, for code compliance and for mandating for a code, we're looking at how can you get more efficient buildings without mandating more efficient equipment, even though that's where people may go. So here are the packages we looked at. So again, efficiency, non-preempted. So we're looking at building envelope improvements, water heating distribution improvements, HVAC distribution improvements, things that we can do that don't mandate people to install more efficient equipment than is the federal minimum. But in reality, those packages may not be what people actually install. People will go out and they'll install and build with more efficient equipment, and that's mostly more commonly probably what you'd see. So we also looked at, well, can you also meet these targets with more efficient equipment? And so we have both of that. We looked at both of those. And then we looked at taking those efficiency packages and adding more PV. Now, for the mixed fuel home, it's already sized to the electric end uses. So we don't have an efficiency plus PV because we're not adding PV beyond what the electricity load is of the house. But for the all-electric option, we have that opportunity to say, well, what's the cost effectiveness if you add more PV? So we have that package. And then for both cases, we're looking at both an efficiency with both PV and battery, where we then can maybe upsize the PV to take advantage of the grid harmonization credits and the benefits with batteries. So for sizing, what we have here is there's several different ways you can size, and for these different cases, for the mixed fuel, we looked at using kind of a maximum PV sizing available to the package. So with a mixed fuel, when we add efficiency, we actually we reduce the demand for electricity, so we can actually downsize the PV system, which is the max PV option. So you can basically trade off efficiency for your PV, for reducing the amount of PVs needed. For the all-electric case, we didn't look at that because you can still take advantage of that additional PV, and so there was more credit available and the cost effectiveness looked better if we could add more. With the efficiency in PV, what we ended up going with was sizing it to about 90% of the electric end use, and this was based upon just kind of optimal cost effectiveness, because there's a minimum bill. Going above that, the cost effectiveness goes down a little bit. But with the efficiency and battery ones, we looked at scaling it to 100% of electricity use, and then adding a 5 kWh battery, which is minimally required for getting credit in the compliance and the software for single family, and then a smaller system per apartment for the multifamily. And then we also assumed time of use battery control for the credits. Also so we understand there's a credit you can get credit for installing a battery in the 2019 code that you can trade off for efficiency. We are using that credit when the battery is installed for all these cases. Although we're not trading off the efficiency, we're just seeing where you can get as far as the delta EDR by utilizing that battery credit. So I'm going to get into the results here. Just preliminarily, there's a lot of information here, and I'm going to be doing it pretty much on a high level. It's because we don't have a lot of time, and I want to just try to show you what we have come up with so far. So this is look, as I said, we were talking about a delta EDR. And is there a microphone that I could grab, because it might be good to point out on the screen, and I don't want to step away from the mic, but so this is basically, thank you. Now I got to find where. So what we're looking at here is a lot of things to parse out of these graphs, but what we're looking at is what we came up with cost-effective packages. So these are the target delta EDRs that we were able to achieve from a cost-effectiveness standpoint. We looked at both kind of the on-bill customer cost-effectiveness and the TDV cost-effectiveness. And in all of these cases, in some cases, it's cost-effective in both aspects, in some it's not. It may be cost-effective in one, but not the other. But in all of these areas, we were able to find a cost-effective package. The only place where we weren't able to get cost-effectiveness is in Climate Zone 7, the efficiency-only package for both mixed fuel and all efficiency. You know, what can we say? You can live in a tent in San Diego on the beach. Somebody mentioned how much further can we go? Well, San Diego, it's like how much further? It is getting more challenging. That was the one place from an efficiency only standpoint. And again, we're limiting this to the non-preemptive packages. So looking at not being able to install, you could find probably packages that are more efficient if you installed higher efficiency equipment, but as a jurisdiction, you're not allowed to go more efficient, have a code that goes more efficient than the federal minimums. So, but what we do see is you're seeing these delta EDRs, and they range between, for the mixed fuel cases, sometimes they're as low as, let's say, 0.5 delta EDR in Climate Zone 8 to 5, a little over 5 for some of these other climate zones. And then when you add the efficiencies in batteries, you can get up there close to or around 10 delta EDR. So that's a pretty significant, and that's ends up being, 10 EDR ends up being like a 30%, equivalent to what a 30% compliance margin was in the old days. But with the all-electric case, we see there's a lot of potential. I mean, you do have the delta EDRs tend to be a little bit higher with an all-electric package. And then when you add PV, because of the fact that this home has, or the building is all electric, and adding more PV, you're directly offsetting that electricity use. You can see you can get quite a bit higher by adding PV. And then on top of that, with all of these, with the efficiency and PV and battery, you can get higher. So now this is the single family greenhouse gas comparison for these same cases. As you can see, now we're got the scales on pounds of CO2 per square foot. You can see the mixed fuel homes have higher greenhouse gas impacts, and that the all-electric, even the standard all-electric, tend to be below, in most cases, tend to be below even the most advanced packages that we have for the mixed fuel. So you see there's the all-electric buildings have, the all-electric homes have lower greenhouse gases. I'll move on to the multifamily if there's no questions there. Low-rise multifamily, very similar. We found packages except, in all cases, except for climate zones 3 and 5 for the all-electric. Tends to be a little more challenging to find efficiency packages with multifamily, just because of the envelope measures have less of an impact on multifamily buildings than they do with single family buildings. They also assume that ducts are already in conditioned space. We can't take lower infiltration credits. There's a lot of things that make it a little more challenging for a multifamily. But again, we can, so you tend to see those delta EDRs being lower for the multifamily. Yes, low-rise multifamily. In this case, we use the prototype, the low-rise multifamily prototype. Again, multifamily GHG comparisons, numbers are slightly different, but as you're seeing, this is per square foot, pounds of CO2 per square foot, but we're seeing same trends. So then I wanted to talk about the looking at the comparison of the mixed fuel case, code compliant case, and the AllElectric code compliant case. Looking at the costs, the incremental costs of the, we did a lot of, took a lot of research and did a lot of studies. Basically what we ended up with is, and the report has this information, I don't have time to get into the details on this, but basically we're finding that the kind of the life cycle incremental costs, which include equipment replacement of different equipment, but is about $4,000 lower for the AllElectric for single family and $2,000 lower per apartment for multifamily, low-rise multifamily. The operating costs tend to be higher for the AllElectric cases as well, and this is a lifetime, looking again at life cycle costs over 30 years of this, but the utility costs tend to be higher. Not always. In some climate zones and some utilities, those change. But what we ended up looking at here was two kind of cases. One, as I talked about, the code compliant mixed fuel versus code compliant AllElectric. But then we said, well, what if you, because with the electric, you can, there's extra PV that can be added to offset more. What if you looked at adding efficiency and PV to that AllElectric case? How does that compare with the natural gas? Yes. So this is kind of the benefit cost ratios we're seeing. From an on-bill standpoint, which again is the customer standpoint, we're seeing about, and just to explain what's on top here is what means immediate, which means that it's lower cost to install and also lower cost to operate, so it's an immediate payback. So in fact, the benefit cost ratio is infinity in this case, in those cases. So, but we're seeing that the benefit cost ratio from an on-bill standpoint is at 1.0 or 0, which means it's cost effective over the life for about half of the climates for single family. From a TDV perspective, it's cost effective in all climates except for 1 and 16. This is comparing, this is the cost effectiveness of the AllElectric single family case versus the mixed fuel case. If you look at the efficiency plus PV, yes. So on-bill is the customer-based cost effectiveness. So that's based using the utility rates, fuel escalation rates for the fuels and what the customer cost effectiveness. TDV benefit cost ratio is using the Energy Commission's basis of. And the difference you see, the big difference you see here between these two is that from the customer standpoint, there's a deduction from the infrastructure costs that are passed on to the utility rates. So you're seeing that while the costs are lower, it's based upon this. With the TDV case, we made this, since we're looking at this from a statewide, what the costs of the utilities are, we didn't have those deductions in there for the TDV case because that's the full, we assumed that the real costs of the infrastructure should be included in the TDV case because that's the true cost. From a customer standpoint, half of those costs, or some of those costs, not half, but some of those costs are passed on to the ratepayer through their utility bills. So when you look at it from when you add the efficiency in PV, you see that it's cost effective, and in most cases, it's immediately cost effective from the get-go because you're using efficiency plus PV to, while you're spending more money up front cost, you're reducing the cost of your utilities. Yeah, dash line is the benefit. That's a benefit cost ratio of 1.0. So anything above that is cost effective. Yes.
Can you just use TDV to show cost effectiveness?
Yes, you can. That's what the state uses as a definition, and that's how code is. All code that's developed every 3 years is based upon that metric. Yes. No. So kind of in conclusion, I think my time's up, but I just wanted to show that conclusions are that we found cost-effective packages across the state for both single-family and multifamily buildings. They're cost-effective under both on-bill and TDV, but not always both. And with the exception of there's those couple of climate zones where we couldn't find efficiency-only packages in single-family climate zone 7 and 3 and 5 for the all-electric multifamily. The all-electric design reduces greenhouse gas emissions by 40 to 50%, what we saw in most cases relative to the mixed fuel design. And from with the code compliant all-electric home was cost effective in about half of the climate zones based upon on-bill, and all of them except for 1 and 16 based on TDV. We have these graphs also for multifamily. They're basically, the conclusions are the same. The numbers are a little different, but basically the graph looks very similar. It's 1 and 16 that were not in multifamily as well. And then efficiency and PV for an all-electric home across the state was, basically the all-electric with efficiency and PV was cost-effective in all cases. Not the 45%. No, we used the fuel escalation rates we used were based upon the E3 study that was used for the TDV that was developed for the 2019 code, which I think is 4.5% nominal escalation rate for natural gas and 2.7 for electricity. So we felt that was a defensible number to go with. Yeah, I mean, there's a lot of variables here that could affect the cost effectiveness, and fuel escalation is certainly one that can change the picture.
Talk about the long-term benefit, right? Is there anything that tells us what the actual cost per square foot to build it? Such a building.
Well, we don't have. I mean, we do have the costs, the incremental costs for all these measures, including when it comes to the base cases. When we're comparing the gas versus the mixed fuel versus the all electric, we're looking at infrastructure costs as well as the impacts of changing from a gas furnace to a heat pump and the electrical infrastructure within the house and the natural gas infrastructure. We're looking at all those cost impacts. For the efficiency measures, we're using the incremental costs. For these cases, we're assuming that all these costs are kind of rolled into the mortgage of a home with a 30-year mortgage. For the customer on-bill cost effectiveness, from the TDV, we're using the costs, and then we're using the Energy Commission's life cycle cost multiplier for. Yeah.
Speak generally to the cost effectiveness outcomes of the storage option, solar storage efficiency option.
So we just quickly, we did find that we found that storage was, these storage packages were cost effective. They were less cost effective than the PV alone. So what we kind of found was that, solar was very cost effective and helping buy down that storage. So we assumed, current costs for storage, but then with replacement costs, we based upon a study that was done by Energy Soft, I believe. Martin Dodd did a battery storage, and so we used kind of future costs of batteries would drop quite significantly at replacement. That's it. Yeah.
I might just be having a tough time balancing the incremental cost and like looking at a delta EDR that's a lot higher for an all-electric building. So I would assume that the first costs of a super efficient all-electric building with solar would be more than $4,000 than a mixed fuel alternative. I think. Can you talk to that a little bit more? Like it looks like the first cost would be a lot higher for a higher delta EDR for all-electric.
So I'm not exactly sure what your question is.
So when we look at delta EDRs, like you were showing for single family, for example,
Yeah.
a much higher delta EDR.
So for those, we were able to get more of, be able to find more cost-effective packages with the all-electric packages.
And that's using non-federally preempted appliances?
Well, the back end of this has about 12 more graphs, which I threw out of the presentation when I realized I didn't have time. It's substantial amount of data, and we have a lot of background on what our assumptions are, as well as kind of, this is, again, a high-level look at what we're doing, but we kind of include tables and graphs that show what our incremental cost assumptions are, what the benefit cost ratios of all these different packages are.
I hear a lot of questions, and I know we've discussed before the meeting here about possibly having a webinar to follow up for the folks that want to talk a little bit more about the technical terms and some of the assumptions and get more into detail. Is there interest in the room for that? Would that be something? We thought that might be. We knew that we had a limited time today. And
we realized 20 minutes isn't enough to go through this. When it took us internally over an hour to go through the results, we realized that. So we'll set something up for I'm thinking the last week in March. So anyway, we can move forward and we'll.